In this lecture, we'll take a look at a couple of applications that use stacks.
What's interesting about stacks is even though we have a very limited set of operations, just pushing and popping on the top of the stack, there's still a very powerful data structure. So what we're going to do in this lecture is we'll look at several common applications that use the stack data structure. We'll start with a very simple application where we reverse the contents of a word. So clearly, one of the things we can do is use a stack to reverse a word. So what we can do is just ask the user to enter a particular word, and then we'll display that word with the letters in reverse order. The approach for this is actually very, very simple. So what we do is for each letter that we read, we'll add that letter to the stack. And then all we have to do is just remove each letter and display it. It's already given to us in reverse order, so we just have to print the letters in the order that we take them out of the stack. Let's do an example. Let's say we want to reverse the word part. We read each letter and add it to the stack. So that means we're going to add the P, and then the A, and then the R, and then the T onto the stack in that order. And what that means is the result of the stack is that the bottom of it would be P, and then A, and then R, and then T. So here, if you're looking at the slide, the right side would be the top of the stack. So then all we have to do is just pop and print each character. So we'll pop the T and print it, pop the R, print it, pop the A and then print it, and then pop the P and then print it. So this results in printing the word trap. The next example we'll take a look at involves balancing very specific symbols. One of the purposes of a compiler is to make sure that there aren't any syntax errors with a program. So for example, if we're missing a specific symbol, such as a curly brace or a square brace and so forth, the compiler is going to report several errors because you're missing that one brace. Usually it's like a ton of errors that's not even related to the missing symbol. Now, I will say that compilers have gotten better at this and been able to identify that the error is with the missing symbol and not so much with everything else. With that said, a useful tool for a program is to have something check the code to make sure that all of these different types of symbols are balanced. So what do we mean by that? Well, we're saying that for every left brace, left bracket, and left parentheses, there has to be a corresponding right brace, right bracket, and right parentheses. So we got to make sure that there are matching parentheses, brackets, and braces. We also need to be able to handle other cases where we have symbols inside of other symbols. So for example, if we have a pair of square braces and then parentheses inside of it, that's fine. But if we have a square brace and then a parenthesis and then a square brace and then another parenthesis where they're kind of closing on top of each other, that's not fine. So we need to be able to handle these types of cases. Let's take a look at some simple examples. So if we have something like this, it's correct because we have C and then we have D in square braces. We have a left and right square brace. So we're good there. Maybe something like this. This is also correct. We have A and E outside of any of the symbols. We have pairs of curly braces. We have a left curly brace and a right curly brace. And then we have a pair of square braces inside here. Sometimes it might be called square brackets, but I might just interchange the term. But we have a pair of square brackets inside the curly braces. We have a left and right square bracket or square brace, so we're good there. What about something like this? Well, it's going to be incorrect because we do not have a matching right parenthesis. So if we take a look, we have a left curly brace, we have a left parenthesis, and then we have a right square brace. Well, first of all, we're missing the left square brace, but if we continue on with the rest of this, we see that we do not have the matching right parentheses, so this is incorrect. This example is also incorrect because we do not have a left curly brace, I should say, where that's needed, because we see that we have this right curly brace here, so it's expecting a left curly brace somewhere. The square braces that are next to the B and the D, those are fine. And we see we do have a left curly brace right here, but this curly brace corresponds to this right curly brace right here. So we need another left curly brace for this to work. And then this example right here, this is also correct because we just don't have a matching right square brace. We have the pair of parentheses, so we're good, and we have a left square brace, but we still need a right square brace that's missing, so this is incorrect. It's actually really, really easy to check these symbols by using stacks. Now, for our purposes, to simplify the algorithm, we're only going to check the balancing of parentheses, brackets, and braces. So the square braces, the parentheses, and then the curly braces or brackets, however you want to pronounce it. But those are the symbols that we're going to check here. Here's our algorithm. The first step is we need to create a stack. It's kind of hard to use a stack if we don't create it. We'll then read all the characters until we get to the end of the file or the end of the string or whatever we're looking at that has all of the symbols. So here we're assuming that we have some code and we're trying to check the symbols. So we'll read all the characters until we get to the end of the file. Now, if we read a character that is an opening symbol, so we're talking about a left curly brace or a left square brace or a left parenthesis, a left symbol, we're going to push that onto the stack. If we read a closing symbol, so a right parenthesis or a right curly brace or a right square bracket, then we're going to check a couple things. We'll check, first of all, if the stack is empty, then we need to report an error, because that means there isn't a left corresponding left symbol with that closing right symbol. Now, if the stack is not empty, then we'll pop the stack, we'll take whatever's on top of the stack, and then we'll compare that symbol with the right symbol. So we're basically pushing only left symbols into our stack. And if we read a right symbol, we're going to pop the left symbol from the stack and make sure they match. If they don't match, and what I mean by that, if we don't have the corresponding left and right symbols, then we need to report an error. And then when we get to the end of the file, if there's still stuff in the stack, that means we have a left symbol that does not have a corresponding right symbol. So here we would also report an error. Let's do an example with the following string where we have A, a left curly brace, B, left parenthesis, C, left square brace, D, right square brace, E, right parenthesis, F, and then right curly brace. So what we're going to do is we're going to read the contents of this particular string to see whether this works or not. Now, clearly we can look at this and see that this should work correctly, but we're still going to go through one step at a time. So we're going to read one character at a time. So we read the A, it's red. It's not one of the symbols, so we don't do anything with the stack. We now read the left curly brace. So since that is an opening symbol, we'll push that onto the stack. We next read the B character. That's not one of the symbols, so we don't do anything with the stack, so we only still have the one curly brace in the stack at this point. We now read the left parenthesis, so that's still an opening symbol, so we're going to put that on the stack. So the top of the stack is now the left parenthesis. So notice that here we're going to put all of our symbols in the stack from left to right, and the rightmost character is the top of the stack. We now read the C. It's not one of the symbols, so we don't do anything with the stack. We next read the left square brace, so that is an opening symbol, so we're going to push that onto the stack. So now the left square brace is the top of the stack. We read the D. Once again, it's not any of the symbols, so we don't do anything with our stack. We now read the right square brace. So since this is a closing symbol, we first check to make sure that the stack is not empty. It's not empty, so we're good so far. So then we will pop the stack. So we take out the left square brace. So we compare the left square brace with the right square brace. They correspond to each other, so we're good. There's no error. Since we're good, we can move on to the next step. So we're going to read the E. It's not a symbol, so we don't do anything else with the stack. We now read the right parenthesis. It's a closing symbol, so we check the stack. We still have something there, so we're going to pop the stack, which is going to pop the left parenthesis, and we see that we have a left parenthesis and a right parenthesis. They correspond with each other, so there is no error. We then read the F. It's not a symbol, so we ignore the stack. We then get to the right curly brace. So since it is a closing symbol, we're going to check the stack. There is something there, so we're going to pop that left curly brace. We see that we have two curly braces, a left one and a right one. They correspond to each other. So we're good. There are no errors with that. We're at the end of the file, so we'll check our stack. We see that it is empty, so there's no error, and we can conclude that this current string or file that we're reading is in fact balanced correctly.